Hi, my name is Omer Farooq, and today I'll talk about how to secure applications that are built around Gen AI or integrate Gen AI capability into existing applications. But before we get started, I'd like to talk about a little bit about myself and introduce myself. I'm a founder and security engineer at Oxford Security based in Maryland. We've been around since 2018, and we have been able to help over 50 different customers build out their digital transformation journey from on-prem to hybrid to multi-cloud. We've been able to help them integrate DevSecOps, including DAST, SAST, and interactive testing and security validation of the networks, and then their phishing attacks as part of their large-scale security initiatives. We are experts, and we take a lot of pride in presenting data as technically close to as with engineering rigor and engineering practices. We make sure that our data is transparently available to not only our customers, but when possible, to our larger audience. That's why we take a lot of our time and we make sure that we present and give back to the community. So today, in that spirit, we'll talk about how to secure Gen AI applications or applications that exist and are integrating Gen AI capability, and what that mean and how to do that rapidly and do it in a way that scales up. So we will start off by a little bit of short introductions about LLM applications. We'll go into how LLM applications are built and what are the challenges. This will include application frameworks and include an application development methodology. And then we'll dive more into how to automate LLM application deployment, either as part of existing tool set or to build new tool sets. And finally, we'll cover LLM security, how to make sure that you strategically build LLM applications secure, and how do we tactically do things to make sure that they are actually built securely by engineers. One of the key underlying themes we would like to make sure that we follow along with this is that we understand that LLM applications are no different from existing applications, but the trick is to make sure that we do not increase the OpEx or the operating costs to expand the application sets or the functionality. We should be able to integrate these new exciting technology into our existing applications without having to redesign or re-engineer our delivery, our integration, and our security. So let's get started and go and talk about LLM applications. So the talk title is LLM SecOps, and I like to put that together and put that together through the Venn diagram that we have on the screen. LLM applications usually are on the form of chatbots that do summarization, do translation. Basically, they are things that are either used by machines or users that are based on the principle of a question or query, and there is a response. But there's much more than that. LLM applications usually have built-in semantic search. They have built-in complicated data rights management platforms. They have a lot of data life cycles. So we'll talk about that as part of our LLM ops. So when we are integrating and we are building out applications with LLM capability, we need to understand how to make sure the data lifecycle policies, the data ownership and classification policies are extended for the current existing applications into LLM applications. And this overlaps with the security. As the organizations shift left, we need to make sure the LLM security shift left at the same time. And thus we'll talk about how to secure the models, how to secure how to ensure data privacy, how to build the data rights management, how to ensure the data is only and granularly available to the right set of people when they're asking a question on a large data sets. So once again, LLM SecOps is a combination of LLM applications, LLM CI/CD automation, LLM security. I like to start out with a high level picture. This is a one view of the world, but it's not, and it should not be considered all reference models. But one common reference model for LLM applications is the model around how to build a chatbot or a machine-to-machine interface that essentially has a query and then gets back a response. And essentially, usually a query is translated to or embedding. Those embeddings are looked up in a vector database to find the closest data set that is related to that. Sometimes this is also used, AI is used to build the right level of query by something called semantic index. The data itself is injected into initial data prompt, and the data prompt is optimized by either building a bigger context or using LLM API to ensure the prompt itself is functional and optimized. And then the prompt is routed through the LLM through the API, or sometimes you have LLM caching. The response is content filtered, and the content filtered response is provided back to the user of the machine. This high-level architecture is not super difficult to understand, but one of the things that I like to point out at this point is that it is important to maybe possibly build a reference application, build LLM applications in two ways. One, keep the front end, the UI or the machine interface, separate from the back end. And this can help organizations in multiple different fashions. From OpEx point of view, building a single large multi-tenant LLM backend can help you build out one backend that has a detailed rights management for data and assets that can be front to multiple different application types, either bots, other translation services, data summarization services, middleware that use the AI, or even other AI services. This decoupling of the front end to the back end will help also with security and the development and deployment of it. We'll show that how decoupling of this application at the back end and the front end is critical in actually making sure security scales up at the same time. Not all front end applications are going to be equally complex, but they will have their own set of requirements. It makes sense to secure the front end applications using current existing non-LLM security models, and then ensure that all the new future LLM security provisions only have to be done once in the large one singular backend that could be fronted for multiple different front ends. What are some of the high-level challenges that are usually part of LLM applications development? One, there's a lot of integrations. LLM applications are data routing applications where a certain amount of data is pulled, certain amount of data is required from sometimes near real-time systems. It could be coming from OT equipment. It could come from IoT. It could come from Bing search. It could come from search engines from specific catalogs. The data could be egress and ingress from all types of data sources. That's what makes LLM applications very powerful. Being able to build and chains of events or change of data interactions that makes the query and the response very powerful. Data integrations represents few critical security issues. All integrations require you to have secure network, all require you to ensure that you have delegated access, and furthermore, it ensures that the data that's being accessed on the based on the initial request user has entitlement to that data that's going to be used for his semantic search, is going to be used for his AI search or his AI query. Furthermore, as the data is being embedded and pulled into the embedding databases, the LLM applications, that data needs to be equally part of your data lifecycle process, with the retention policy, data classification policies, and data catalog and tags and labels. This becomes a difficult challenge when you're dealing with a lot of data with at scale for different front end systems. We'll talk about how to use specific tools and technologies and concepts to build that out. That's part of our LLM ops. And finally, if not equally important, is the AI services. It is possible an AI application or AI backend that is LLM application backend will interact with multiple models, if not one or more. We need to be very careful about how those model integration and models APIs are protected, not just for cost, but also for availability, ensuring those metered services are logged, making sure those model communications are protected over the public internet with at least with some level of data encryption at rest. The data itself, when you're inquiring from the user to all the way to the model, can potentially include a lot of proprietary, if not sensitive data, including personal information, including things that could be considered privilege. Thus, AI API model security is equally important and needs to be considered as part of the LLM application security. We'll cover this and we'll talk about how that can be secured as part of our LLM SecOps, which is in the latter part of this conversation. So before we get into a little bit of how and what LLM applications look like, I like to start out with saying, let's put a developer hat on. And how do you build an LLM application? Or how do you actually add an LLM application capability into existing application? You have two major components. You have the actual logic and of data integration, and then you have the model. Understanding and using the right model is very important. That also is equally important because not all models offer the same type of security and responsible ethical AI capability as other models. Pulling an open source model from public internet versus a model that's managed and curated has different set of side effects and different consequences. Be careful when you choose the right model. Also, like as we mentioned prior, keep the front end of the application, the bot, the user, or the machine-to-machine interfaces separate. And try not to consider those as part of the LLM applications as much because those could be factored out and developed using existing application interfaces or with low-code, no-code solutions. And keep a focus on building one-time an LLM backend that could be secured with data rights management and other features and does not have to be redeveloped. Another feature of LLM applications, this is very important to cover because this dictates how security and how development works, is the fact that LLM applications are cloud-native artifact. They were built in the cloud. They come from most of the development is in the cloud. And that means is that a lot of the components, part of the rapid prototype and fast results methodology for LLM applications require to use a lot of open source data router frameworks like LangChain, a semantics kernel, and Llama index. You will have a lot of components of open source. If not, the entire model could be open sourced. You will be using a lot of low code, no code for your front ends. You will be leveraging a lot of cloud services, including serverless and managed services for AI and AI related compute and storage. And most of the times, if not all, you will be utilizing some kind of a vector database that will be sitting in the cloud or could be on-prem that needs to be protected equally, just like the way we protect traditional databases. Though the purpose of the vector database is a bit different and the capability is different and the data context is different, we still need to protect the vector database equally as how we protect traditional relational and non-relational databases. Before we get further, I like to point out three large principles for data application security for LLM applications. One, decoupled architecture. Applications should be cloud native whenever possible. Applications should be managed services as much as possible. And vector databases should storage and performance should be considered. Now, these principles are not entirely for LLM application development, for secure development, but they're part of general principles that you should consider. Decoupled architecture will provide you better return on your investment, Applications in cloud native will allow you to do rapid prototype, which is part of what all applications are built like. And vector databases that have higher performance and storage functionality will allow you to make sure that you have the data rights management at scale, so you can build a decoupled architecture that we want to build for security. So the next concept that we want to talk about is, now that we know what LLM applications look like and we understand the design principles and how the methodology for LLM application is, which means fast prototypes, build fast, fail fast. How do we do that? And that is basically, and how do we do that with existing tools, and how do we do that without learning new tricks, and how do we make sure that we do it quickly in a way that we don't slow down the prototypes and the development? Going from Jupyter Notebook, for example, to an application can be done in quite literally over a few hours. But when you do it at a scale and do it from an organizational point of view, how do you bring all those teams together? You can use your existing pipelines. The good news is, if with the additional of a few stages and steps in your cloud native or your on-prem automation, you should be able to support LLM applications. How do we do that? Let's start with automation and deployment. The backend applications that are part of the LLM applications are no different. They are still cloud native, but the minute differences are about the configurations of the model, how to integrate the keys, and how to integrate the service accounts. All of those should be deployed and automated in a similar fashion as we do today. Integrations of secrets, integrations of tokens should be done in a similar fashion as we do today, except with the caveat that, remember, a lot of the applications today for LLM are metered services. In that scenario, we do suggest to pick up the speed and use delegated access. Whenever possible, make sure that you build LLM apps within your application to utilize the end user's credentials, the end user's identity for meter service. Pass that responsibility out of the model and don't manage it at a large level. Manage it at the user or the organizational department level. Build new indexes and new detections and new threat detections in your SecOps tooling for LLM apps. They won't be that different for your existing, but they will require to have separate LLM SecOps and detections, for example, for prompt injection and data and prompt poisoning. You will need to build that in the threat detection. For example, if you see a user continuously trying to do prompt injection, you need to build out new threat detection scenarios in your SIEM tool or your threat intelligence, threat hunting tool. You need to pull in the feeds for threat intelligence to make sure that they include the LLM application types. And if not the last and the most important, data management. You do need to enable encryption at rest, encryption in transit, encryption in use. We need to make sure the embeddings, the question and the answer, the responses that are logged into the application, that are logging the data, the questions that are asked by the user of the services are considered privileged information. One of the key things we need to make sure that the part of the LLM ops is that you need to make sure there are column, if not in column level encryption, to protect the response and the requests that the application will see. This can be considered equally privileged as two people's conversation, because people and users will ask and inquire things that are either very personal or PII, include PII, or do include company private, company sensitive, or general sensitive data in their queries. The queries have to be protected, have to be only available to certain users. The audit trail and the investigative and the forensic investigation should only be available to certain users. The data rights management of the log data is a critical component. And we suggest using column encryption. We suggest using double encryption to make sure those columns where the data requests and data prompts are protected. Before we get into LLM SecOps, security ops, we need to cover some of the high-level privilege and what are we really protecting and trying to gear towards with an LLM application, and how is that different from a traditional application. Traditional applications are also equally worried about data leakage, but they are less worried about prompt injection. They're less worried about model poisonings to some extent because sometimes there are no models. Adversarial attacks against LLM applications are different than from the nature of the attacks that are for existing non-LLM applications. For example, adversarial attacks on LLM application could be to introduce LLM hallucination. And finally, the ethical concerns are primary part of the LLM SecOps, and how do we make sure we manage those? So let's start with ethical concerns. Ethical concerns are something that we should think about when we're building out applications, and those could be tuned using content filtering. Data leakage can be addressed using data rights management and double encryption and column encryption. Adversarial attacks can be protected and detected using SecOps and threat detection and threat intelligence. Model poisoning and prompt injection can be protected using the traditional input validation, metered throttle responses, content filtering, and those type of built-in cloud resources for making sure that the model stays protected and inputs are checked. Next, but finally, we get to the point where we can actually do things today to protect our LLM applications. I filed them under the tactical LLM SecOps. And essentially, these are the few steps at high level that we can take today using existing tooling to protect our LLM applications. Number one, use your existing tooling for DAST and SAST to ensure that all LLM open source components, that includes SCA, that includes using SCA tools or using SAST tools. Make sure all the code that is written for your LLM application is equally goes through your secure coding practices as your other code, even though it might be cloud native, even though it might be more configuration heavy, even though it might be something that looks as a serverless function. All of this code needs to be protected and reviewed. We suggest using tools as existing pipeline steps to run scans of this code, making sure that these particular code snippets or the code libraries are able to protect against prompt injection, are able to protect against model poisoning. There's certain different tools out there that are able to look for these kind of patterns within the LLM-based type of code. So if you have code that is able to do build semantic index or is able to do response or input query caching, you can build out and scan this particular piece of code with these scanners to ensure you are focused and hyper-focused on finding those vulnerabilities. Ensure that content filtering is both ways, at the input and the output. Ensure the model is not able to accept PII, or is able to accept PII if needed, but to a certain limitations. Make sure the data that gets ingressed into the model is classified, is labeled, is tagged. Those are the things that at the code level you can check today. You can make sure that the rights management with your backend logic is tested and using DAST and other validation tools. And last, if not least, ensure all your logs for all your LLM applications are end to end, and they're able to capture data capture from user to machine and back to the user. In case you need to go back and trace out LLM interactions, to either find detection of abuse or detection of illegal data usage or model hallucination or model prompt injection, those logs will be critical. Thank you for joining me today for this conversation about LLM security ops. I hope you had enjoyed this conversation and took away the key points about how to keep the data front end and the back end separate, how to build up the automation and the security from a shift left perspective from day one in your LLM applications, or adding the capability of LLM into your existing applications. If you have any further questions, or you would like to have a dialogue, or if you would like to have questions or feedback, feel free to contact us at www.oxen.io, My email is Farooq at oxen.io, and I'm always happy to respond back to constructive feedback. Thank you, and have a great day.